Okay, today we're going to evaluate the limits at infinity. When we're talking about the limits at infinity, we're really trying to describe the behavior at the horizontal asymptotes. Okay, so let's look at this graph of f of x over here. It says the limit as x approaches negative infinity of f of x. So x is approaching negative infinity on the far left side of the graph. As I move to the left, the x moves to the left, the y value is getting closer and closer to y equals 1. So the limit as x approaches negative infinity is going to be 1. If you want to write 1 from the negative side, that would be that it was just below the line y equals 1. Okay, now the limit as x approaches positive infinity. X is approaching positive infinity as I move right. The y value is getting closer and closer and closer to y equals 1. So I'm going to say that the limit as x approaches infinity of f of x is 1, and that's because of this side. The other one was because of this side. But it is describing the behavior of the horizontal asymptote. There is a horizontal asymptote at y equals 1. Let's look at this other graph. Okay, so for this is also a graph of f of x. Limit as x approaches negative infinity. So on the negative infinity would be this way. So if I follow this graph here, it's going that way. It looks like it's approaching y equals 0. Looks like it's touching it, but it shouldn't really be touching it. To be descriptive, you could say 0 from the positive side, but it's not necessary. Okay, now as x approaches positive infinity, the graph's going this way. And as I go this way, the y value is getting closer and closer and closer to 3. I could say 3 from the negative side if I wanted to describe that it was just below the horizontal asymptote. Okay, so it could be different on either side depending on the behavior of the graph around the horizontal asymptotes. Now we're going to evaluate the limit as x approaches infinity or negative infinity of different algebraic expressions, which can help you describe vertical asymptotes and things like that. Okay, now if I wanted to use direct substitution, I would get 5 times infinity plus 7 over 2 times infinity minus 3, which would give me infinity over infinity, which is basically indeterminate. So I need to play with this a little in order to make this work. So the strategy normally is look at the numerator or denominator, and you don't want to divide by the leading term, the leading variable term on either. So 5x plus 7, x is the highest degree term on the top, so I'm going to divide everything by x. And then I will show you why in a second. Hold on, let me spell limit correctly. Limit as x approaches infinity. Okay, if I divide everything by x, 5x divided by x is 5. 7 divided by x is 7 over x. 2x divided by x is 2. 3 divided by x is 3 divided by x. Now the reason I like this, let me write this out. I'm going to go ahead and plug in infinity. Am I going to? No, I'm not. I'm just going to imagine I plugged in infinity. Okay, now imagine I plug in infinity here. If I do 7 divided by infinity, 7 divided by infinity is going to approach 0. So I'm going to get 5 plus 0. In the denominator, if I plug in x, 3 divided by infinity, like $3 divided by the entire universe, means everyone gets nothing. So it turns into 2 minus 0, which I can evaluate. So the limit is actually, as x approaches infinity, is 5 over 2. And if I were to graph this, this would help me determine there is a horizontal asymptote at y equals 5 over 2. Okay, I'm going to go ahead and do the next one the same way. I'm using the same strategy for example 2. They're all going to be very similar. Example 3 will be similar but different. Okay, so if I look at the next one, I want to plug in x as infinity, direct substitution, which sometimes you can get away with. But in this case, I'm going to get infinity to the 4th, infinity, blah, blah, blah. And the bottom, I'm going to get a bunch of infinity stuff. Infinity over infinity is indeterminate. So I'm going to look at either the leading term on the top or the bottom. It actually doesn't matter. Some people just pick one way and others do the other. So this is x to the 4th. I'm going to divide everything by x to the 4th in the numerator and the denominator. And I'm going to keep writing limit because I have not yet plugged in infinity. Okay, now I'm going to divide everything by x to the 4th. So negative 12x to the 4th over x to the 4th is negative 12. 3x over x to the fourth is going to leave me 3 over x to the third, because the x canceled, minus 7 over x to the fourth. And if I divide all of the denominator by x to the fourth, I get 3 minus 2 over x to the third over x to the fourth turns into an x at the bottom. Okay, now if I plug in infinity, this thing turns into 0, this thing turns into 0, and this thing turns into 0. So this is going to simplify down to negative 12 divided by 3, which gives me negative 4. And again, this is describing any horizontal asymptote that would occur in this graph would be at y equals negative 4. Okay, let's do one more that's similar to this. Okay, again, if I tried to plug infinity in the top and bottom, or this is negative infinity, I would get like negative infinity cubed minus 7, negative infinity cubed plus 4, indeterminate. Okay, so if I look at the leading term on either the top or the bottom, I'm going to divide everything by x cubed. If I divide everything by x cubed in the numerator and denominator, I get 1 minus 7 divided by x cubed, 1 plus 4 divided by x cubed. Now, if I do 7 divided by negative infinity cubed, this still turns into nothing. Whether I'm dividing by positive or negative infinity, it's going to turn to nothing. And same here, 4 divided by negative infinity cubed is still 4 divided by a very, very large infinite number. So when I simplify this, it turns into 1 over 1. So my answer is just 1. Okay, now for all of those examples, the degree of the numerator and denominator were the same. So for the next one, next two, I'm going to change up the degree. Okay, I'm going to go ahead and look at this one. It says limit as x approaches infinity of 5x plus 7 over 3x squared plus 5x. Again, if I plug in infinity, I get infinity over infinity, which is indeterminate. So I'm going to look at the numerator and denominator and divide by the leading degree on either one. I might do this two ways. Let's see if I actually do it. Okay, so if I look at the numerator, the highest degree term is the 5x. So I'm going to divide everything by x. That'll leave me 5 plus 7 over x. And the denominator, if I divide everything by x, I get 3x plus 5. Okay, now when I plug in infinity, I get 5 plus 7 divided by infinity is 0. And the denominator, I get 3 times infinity, which is some kind of infinity, plus 5, which is still some kind of infinity. So I'm essentially getting 5 divided infinity, which will turn into a 0. Okay, now I could have also divided by the highest degree on the denominator. Let me do that real quick. Because sometimes I feel like one of them is easier than the other, although it doesn't make a difference to me. Do I have space to fit it right here? Let's try. Okay, now on the denominator, the highest degree term is x squared. So what if I divide everything by x squared? If I divide the numerator by x squared, I get 5x over x squared, which is 5 over x, plus 7 over x squared. And the denominator, if I divide by x squared, I get 3 plus 5x over x squared turns into 5 over x. Once I plug in infinity, in the numerator, I get 0 plus 0. In the denominator, I get 3 plus 0. So I still have 0 divided by 3, and I still get 0. So it actually doesn't matter whether you divide by the highest term in the top or the bottom. You should get the same answer. Okay, let's try B now. And yes, I did just change that to 4x to the fourth. I'll try to fix it on the blank one. Okay, I'm going to plug in negative infinity. But again, you can divide by the highest degree at the numerator or the highest degree at the denominator, or just the highest degree overall. You should get the same result no matter which way you do it. I think I'm just going to do whichever one's highest overall. So since the highest degree overall I see is x to the fourth, I'm going to use that one. But you could divide everything by x squared. We're going to get the same result. If I divide by x to the fourth, I get x squared over x to the fourth is 1 over x squared. 3x over x to the fourth is 3 over x cubed. 7 over x to the fourth. On denominator, I get 4. X over x to the fourth is 1 over x cubed plus 1 over x to the fourth. Okay, and then in the numerator, I have 0 plus 0 minus 0, which is 0. And the denominator, I have 4 plus 0 plus 0, which is 4. So I'm going to get 0. So the fact that it was negative infinity didn't make a difference. It just means on the left side of the graph is going to respect the asymptote of y equals 0. Okay, for the last example, the degree of the numerator is actually higher than the denominator. Okay, but the method I do it is going to be the exact same way. Okay, so again, I don't want to plug in infinity because I'm going to get infinity over infinity, and it's going to be indeterminate. Okay, so I'm going to divide by the highest degree on the top or the bottom to everything so that I can make a bunch of stuff turn into 0. Let me divide by x squared. If I divide by x squared, I get 5 plus 7 over x squared. X over x squared is 1 over x plus 4 over x squared. Okay, when I plug in infinity, 5 plus 0 is 5. 0 plus 0 is 0. Okay, 5 divided by 0 is some kind of infinite value. So this is going to be unbounded. It's probably going to approach positive infinity, but I didn't examine the approaching very well. So does not exist will be a good enough description of this. Okay, and if I had chosen to divide by x, which I could have done, I would have ended up with 5x over 1. And then when I plug in infinity, I would have 5 times infinity over 1, which would have been infinity over 1, which would have still been unbounded, and the limit still would not have existed. Okay, let me look at the next one. Okay, should I divide by x squared or x? I'll divide by x squared again. Okay, when I plug in negative infinity, I'm going to get 1 plus 4 times negative infinity squared is positive infinity. I'm going to get 0. And the denominator, I'm going to get 0 minus 0. Now, weirdly enough, I'm actually going to get 0 from the negative side, but I'm not going to worry about that right now. I'm going to get some kind of undefined value. So this is going to be unbounded because Kahn likes to call it unbounded. But because it's unbounded, the limit does not exist. And we didn't describe the behavior as well as you might do in the future. This would actually go to negative infinity if we inspected it a little more carefully. Okay, I'll do one more. You could divide by x to the 4th or x squared. Maybe I should do x squared this time to make it different. I'll do x squared this time. If I divide by x squared, I get negative 3x squared over x squared divided by x squared is 1. Okay, now if I plug in infinity, I get negative 3 times infinity squared over 1 plus 0 is 1. Negative 3 times infinity squared is some kind of negative infinity divided by 1. So most likely it's going to negative infinity, but either way I can tell this is going to be unbounded, which means the limit does not exist. But the reason is because it's unbounded.